Welcome to all. This is Engineering Mechanics class number 383 all together, which includes part 1, part 2, part 3, part 4 and part 5. If I remember correctly, part 1 forces and resultant, part 2 different types of loads, part 3 is equilibrium, support reaction, etc. Part 2 is equilibrium, support reactions, etc. Part 3 is centroid and moment of inertia. Part 4 is friction, and part 5 is analysis of statically determinate pin jointed plane frames. For part 5, this is lecture 66. Overall throughout 383, for entire all the 5 parts 383, and one more thing, for part 5, question 105 is the last question for method of section. Last class, I told question 104, last question for method of joints, already uploaded. So today, last question for method of sections. And incidentally, today's class is the last class for engineering mechanics. Next class, the most powerful strength of material. I will make some announcement regarding that one. Okay, now make a note here. The question is, for the given pin jointed plane frame, find axial forces. See, I never write find forces. I write find axial forces. Force is different from axial force. Moment is different from bending moment. Same way, force is different from shear force. So technically you should talk. Okay. Find axial forces in all members. Not all members. Sorry, it was last time. By habit I read. This is method of section. For the last time question was, see, I'll tell you, note. Solved in detail last class by method of joint, where I wrote, for the given pin jointed plane frame, find axial forces in all members by method of joint. Uploaded. Okay, now today, for the given pin jointed plane frame, find axial forces in the members. 3 groups are there: EF, BF, and AB. See, I'll tick here: EF, BF, and AB, one group. Then, so for that, what we will do? We will take a section here this way later. EF, BE, and BC. Next one. EF, BE, and BC. We will take a section here. Okay. Next one. This all you should observe. See? Okay, I won't use the pen now. Become difficult. Last one. See, it became little dull here. Okay. Okay. Last one. EG. See. EG, DG. Not DG. EG. Then DE. It should be DE here. Okay. Misprinted. DE. Okay, I'll change it. EG, DED or DE, and CD. That is, we will take a section here. This. All by method of section. Okay. Now, I will explain again later. Some statement I will tell now before I start. Very important. Class. Note. See, I told last question for method of section. Therefore, I am going for detailed solution. Any confusion if you have got earlier regarding that arrow mark, etc., will be clarified today. Or systematically I am solving. Well, so this is not exercise question. Last chance to learn the method of sections systematically if you are learning from me. Otherwise, you learn. Okay. Now, very important, I told this one. Now, some statement you have to write. Class, I will continue. See, those who are serious should write. Whether it is method of joints or method of sections, if one hinge, one rows are given, you require support reaction. I already told you. In case both are given hinged support, with only one member attached to one of the hinges and no member connecting the two hinges, special case, it is statically looks like indeterminate but actually determinate. For that, you need not find reactions. You look the other side, free end side, where support is not there. Already class uploaded. I told the principle, etc. You search there. Special case, or I told problems also solved. Go through it. Okay, now this is regular. Okay, now first is calculation of support reaction. Last class we finished it. At last class I told, see, next class I am solving the same question by method of section. But today independent, not very. See, earlier what you used to do? Find the forces in all members by method of joint, verify the result for some members. You are verifying. No, this time independent question. So you remember, this is all independent question. Independent question. Do not worry about method of joint. Right here. You write here. Never bother or not, never bother about method of joints today. You don't bother about it. But one thing you have to bother, when you find support reactions, whether it is method of joints or method of sections, same. Last class, actually support reactions I should not explain. It is already over in part 2. So many examples given, and method of joint, question number 105. How many in the beginning all I used to explain reaction very systematically. So nothing required. Even then, last class, when I solved this frame by method of joints, I explained thoroughly support reaction. Then I told you, when I take next class, same question by method of sections, of course, independent. Support reaction will come. I will not explain. But I will write everything. What I wrote yesterday, I write. See, let VA and HA be vertical reaction, horizontal reaction at the hinge support at A. You should know hinge has got two reactions. And let RB be reaction normal to plane of roller at B. See, normal means reaction RB. Since it is this way, it is equal to VB. See, this also I told VB. Okay, now write the sketch once again. 5-4. See, last time what happened is, when I gave the question, I forgot to give this 3 meter. But later, I wrote 3 meter here. Missing data, not missing data. I took the 3 meter. It was rubbed out. I wrote 3 somewhere here. Then due to some reason, I rubbed it. Okay, so it is 3 meter. Last question. No, no one should tell. The height is not given. See, I told the height there. These are all simple matter. So 3, this is 2.5 extra height. And this point is not midpoint. See, this is 4. Midpoint is 2 and 2. This is only 2.4. So this is 1.6. This is all I told. Now take moment about A. Why moment about A? I told last time. About the point where more unknowns are there. So clockwise positive, minus VB into 5 plus 6 into 9, 12 into 0, no need of writing. Minus 8 into 3 anti-clockwise. I minus because anti-clockwise. 16 into 5.5 clockwise. So plus 15 into 5 plus 1.6 is 6.6 clockwise. So plus 18 into 0, 40 into 3 clockwise equal to 0. You get the value of VB. Sigma V0 plus VA plus VB minus 18 minus 10 minus 15 minus 6 equal to 0. Substitute VB whatever you got. See, VA we got minus 28.4. Very important now. Okay, then sigma H0, right side positive, plus HA, plus 40, plus 16, minus 8, minus 12, 0. You got HA minus 36 kilometer. Now it is ready for method of joint. Now do one thing, you write one more thing. Also, I forgot last time. I told also after this one, write one more thing. Also, right here, find angle of inclination for inclined member. Inclined member. So you take here only in this sketch only, mark this theta 1, mark this theta 2, mark this as theta 3, mark this as theta 4, and get the value of theta 1, theta 2, theta 3, and theta 4. Get this value. This side, okay, see, not required. You should get it. Tan theta 1 is 3 divided by 5. 3 divided by 5, shift tan inverse answer. 30.964 degrees. 30.964 degrees. Tan theta 2 equal to 3 divided by 4, not required, 36.870 degrees. 870 degrees. Tan theta 3, see, draw a light vertical line. So, this side by this side, that is 2.5 divided by 1.6. Shift tan inverse answer. 57.381 degrees. 57.381 degrees. Lastly, theta 4, 2.5 by 2.4. 2.5 by 2.4. Keep tan inverse answer. 46.169 degrees. Not visible? Okay. Theta 4. 46.169 degrees. These values you require. Get small I written, zoom little, or see in the laptop visible. These angles are there. Actually, remember, make a note here. In method of joint, you require all the angles. If it is method of section, see, when you find for EF, BE, BF and AB, you require only theta 1. If the question is these three members, only theta 1. Don't waste time for other angles. Then, if this member and this member, no angle of inclination required. Don't waste time. Whereas, next which one? Lastly, this one and this one, you cut here, you require only this angle. So theta for today, we don't require, but still I wrote it. Okay. So when you do method of sections, whichever member required, find the angle. Okay. Now it is ready. Now what I will do is this everything I am removing this side. Even this everything I am removing. This sketch I am not removing because I told you in method of joint you write one more sketch where you enter, see, VB upward of 77.4, VA you took up, negative side came, so down 28.4, HA you took right side, negative came, so left side of 36, that you mark in method of joint. But method of section, that I used to call star sketch. Then you take photograph after photograph, systematically, progressively make entry there. But in method of sections, not that way. This is our star sketch. See, this is our star sketch for method of section. Remember, this is our star sketch. When you want method of section, you use this sketch only. This sketch only use it. But remember, when you use this sketch later, in case you require VB, you should take how much? Upward of 77.4. In case you require VA, we took upward, negative sign came down of 28.4. And if you require HA for any reason, you should take HA. See, we took right side, negative came left side of 36. This I will not tell once again. So later, you will refer the sketch only. Here only, we will show all the sections all. Everything will be this sketch. Now, what I will do now is full I am removing. And what I will do is, somewhere here, I will put the recap. See, I told you it is an independent question for method of sections. I told, do not bother, never bother about method of join today. But since this question is already solved, you need not bother. But I have to bother because answer has to come correct. So, only for information, I will write here, only for information, what result we got last time by method of joint, I will enter somewhere here. Only for little small. See, this space I want. This space I want. See, here space is there. I'll write here so that as we solve by method of sections, we can get confidence. Yes, correct answer. That reason I'll do it. And one more thing, I told many times for you. If you got proper knowledge, proper grip, and correct understanding, once you get this one, if you want to gain for that matter, so many questions, so many chapters in structure engineering. No, leave it. Especially this particular chapter, method of join, you can get the answer directly without writing anything, standing here with a calculator and operating. That's what I am doing now. Just to give you inspiration, not for show off. Don't tell I'm doing for show off. Some will tell he is showing his capacity. Yes, I'm showing my capacity for that matter. Yes, I got capacity, but I already shown it so many times. I offline people they know it. So, but see, so far in my entire teaching, not a single day I took one small piece of paper. I come with calculator, pen, and in RCC and steel, you wear IS code. IS code is not copying. Codal provision. Otherwise, engineering mechanics, strength of materials, structural analysis, stat, determinate, indeterminate, finite element method, or matrix method, then the theory of elasticity, dynamics, any subject, I directly come to the class and take the class. Questions also, I never come prepared for the question. When I come to the class, I write the question. I got confidence. Result will come perfectly. So, just to give you confidence, see, you should think that way. When he can do it, why cannot we also try one day? So, just to give inspiration, result I'll put in front of you only. I'll enter here now. I'll prepare the frame here when I rub the board, but solution I will do in front of you. Oh, okay. I'll start now. I will enter the answers. Anyway, for your information or for those who can understand, I will little tell the steps. But if you can understand, okay. Otherwise, see, this is actually directly using calculator. Don't go for adventures like this. Okay. See here, some rip down 28.4, nothing to balance, up 28.4. Here, other opposite. 20. I will not go, I won't waste time here. See, just for information, you write here This is the result we got by result we got by method of joints last class. I want it kilonewton. Space is not there. Then 36 kilonewton. I will come to joint F now. At joint F, 18 down, 28.4. A calculator is not on. 18 down, 28.4 down. So that is total down divided by sine 30.964. 90.185. 90.185 kilonewton into cos of what is angle 30.964 this way, subtract 40, I will get what is this one? 90.185 into cos of 30.964 minus 40 is 37.333. There's not something wrong in the calculator. 90.185 into cos of 30.964 minus 40. It has taken only 4. That's why getting wrong answer. 37.333. 37.333 is the answer here. We got last class. Then I will go to joint B. If I go to joint B, any of joint you can go. 90.185 into sine of 30.964 is 46.4 down. 46.4 down. Down means further you require down here. That is guaranteed. Minus 77.4. It will give you 31 kilonewton. Exact 31. Then 90.185 into cos of 30.964 is horizontal component. That's all. That is acting right side of 77. So you require to balance by once again this way to balance it. I subtract 36 minus 36 equal to 41.333. 41.333. Then I will go to joint C. If I go to joint C, already how much is there? Horizontally should balance first. 41.333 minus 12, that is 29 point something, divided by cos 0.8 will give 36.666. This way. Space is not there. Use space problem. Okay. 36.666 kilonewton. Vertical balancing into sine theta is actually acting upward 29.83. I will subtract 6 equal to, no, something wrong. One force missing there. 36.666 into 0.6 is 22. 22 is up, minus 6 is 16 down. Carefully I am doing. 16 down. Now, last time I went to this joint, but now I go to this joint. I don't want to waste time. I will balance vertical now. 16 divided by sine of 46.169 will give that force. 22.180. It is this way. Space is not there. 22.1795 is 180. 180 kilonewton into cos 46.169 will give you 15.36 right side. I will subtract 8. I will get 7.36. Right means left side. Left side of 7.36 I will get here. 360. Lastly, I will come to joint G. 22.180 into sine of 46.169, that is upward component 16. I will subtract 15. As I subtract 15, I will put arrow mark now only because I know the direction now. This way. Okay. 16. Whatever I get, I will divide by sine of 57.381. 1.188. Space is not there. 1.188. Anyway, you see the last class. Last sketch, big written. So this is for information I want. This is the answer. Now, checking is not required. I will do one thing. Before I continue recording, by chance, if any mistake is there, I will go to YouTube, open my recording and see the last time class and compare. Then if it's correct, I will start method of sections. If wrong, I will tell you what is wrong. Okay. Okay, remember, this is the sketch used for, you can consider this as a star sketch. This is star sketch for method of joints. See, this only just for information. Everything is correct. Last class, I wrote 22.179 because of rounding off error. Today, since I did in calculator, that error reduced. It became 22.180. That is not a problem. Okay. Now, also note, we got a VB plus 77.4 kilonewton. VA, we got minus 28.4 kilonewton. And HA, minus 36. Remember it. Okay. Now we will start method of section. First class, something I will dictate. You should write. In method of sections, this all told. You should write it. We first decide forces in which members or axial forces in which members are required. Group will be there. Method of section is used not to find forces in all members. If you want forces in all members, ideally is method of joint. Nobody will go for method of section. So method of section is very important when you need forces somewhere in between. See, method of joint, you start from one end. Slowly you have to go. Suppose you want force here. See, from here you start, come here. Or from there you start. By chance, see, suppose there's a big frame is there. See, for example, maybe a bridge truss. See, right here. Some bridge truss. Very huge. Some truss. Okay. This way. Okay. Now, suppose you want forces in this member, and this member, any of these members. Then, if you do method of joint, you have to start from here. Slowly cover this joint, 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 then this joint, or from there. But method of section, not that way. Directly cut and start. So, the advantage of method of section is when you require axial force in particular members in between, it is very useful. It is highly useful when you draw influence line diagram for axial forces in pin jointed plane frames. It comes in structural analysis, or in case of design problem, bridges solve. Suppose for some reason you want forces, axial forces in some particular members, method of section is very useful. Okay. Now, in method of sections, once we decide in which members we require axial forces, you consider a section cutting those members. Number of unknowns should not be more than 3 because method of joint, when you consider, we are considering joint equilibrium, concurrent force system, sigma V, sigma H, only 2 unknowns. But method of section, see, when you cut here, you are seeing coplanar force system. So three equilibrium conditions: sigma m0, sigma v0, sigma h0, always apply in the same order: sigma m, sigma v, sigma h. This all told earlier in the theory. I am recapping it. Okay. Then, if it is an independent question, you should first, once you cut or pass a section, you consider equilibrium to any one side, whichever side is better for you, easier for you. In case you are solving both end pinned, consider free end side, because reactions you are not finding. Okay. When you consider equilibrium, which side you are considering, on that side, write all external forces like support reaction and outside external forces. Consider external forces. Then, which member you are cutting, for those members towards the joint on the inner side. If you look this side to the left side, if you look right side to the right side, forces coming from other side. See, when I cut here, for example, if I cut here, look this side. These are external. Forces will come from these three members this way. So many people, they tell internal. No, it is external. I will show it once again now. This in the YouTube later. I am giving one more information for you. So not much I will talk now. People who tell it is internal, I will prove it is wrong. It is external. Okay. Or I will explain now. Consider the forces acting towards the considered side. Forces acting towards the considered side. If you consider left side, from that side, what force acting to this side? If you consider right side, then from that side, what force acting to this side? Or along the member, consider forces acting to our considered side. Considered side. Okay. Then, if the question is to verify the result, see, suppose in the question they ask you earlier also, first solve by method of joint. Verify the result. If you are verifying the result, you know the answer here and you know the direction. In such cases, you are verifying means what? You know the answer. When you know the correct direction, who will take wrong direction? So in that case, you take what direction we got here and you will get plus. Plus means assumed is correct. But if it is an independent question, see, I told you today's class, this you are not supposed to see. This is only for our personal verification. You should not see this one now. If today we are solving independent question. If it is an independent question, then those unknown forces along the members direction you have to assume. If you think it is possible to decide correct direction, but deciding correct direction for method of joint is very easy. I explained to you earlier lot of examples. How to decide perfectly one class around more than 3 hours. But deciding correct direction for method of section requires very what I will tell you, very high level. You have to imagine so many things, how the moment will come, which is predominant, and how the balancing is done. I will tell 99% people it is beyond their capacity. Maybe 1% people will be there who can decide correctly for mixed uploading. But when you go for ILD, at that time I will tell you how to decide. That is there, just one unit load is there. Here so many loading is there. So it is very difficult. Not for me, I can tell correctly, but it is not what I can do counts here. What I am teaching, what you understand counts. It is not my capacity you are seeing here. Therefore, what I will do, I told more around 99% people will find it complication. So I should go for majority. So therefore, if 1% people who can decide, okay, you decide. Why ask me? Decide correct direction. Somebody will tell, sir, I can decide. Decide then. Good. Why you are worrying? But I have to consider other people, majority. So what I will do is only for method of section, we will consider the unknown forces going away from the joint. Going away from the joint. If we assume going away from the joint, that means later when you see here it is only a force, external force, but later when you consider for a member, it becomes tensile. I will explain it later. So when you solve an independent question for method of sections where result is not available from method of joint, if result is available from method of joint, see, suppose you cut here for this side if you are seeing, see, if you cut here, look this side, I will explain later. You consider these arrow marks coming to our side. I will explain later. But our question we decided independent. So better assume it coming towards the joint, sorry, going away from the, anything will do, going away from the joint. Once you assume going away from the joint, that means you are actually assuming tension. Okay. Or if it comes positive, it means assumed direction is correct. If it comes negative, it means assumed direction is wrong. That all I will explain for you and make full clear now. Okay. Now this all over. Then right. Once you consider equilibrium to one side, any one side of your choice, then apply. See, you should not have unknowns more than 3. So apply sigma m0, sigma v0, and sigma h0 to one side equilibrium. Sign we take usually clockwise positive, upward right side. Okay. Then these are simple, only vertical component, only horizontal component. But when you apply sigma m0, moment about which point? See, about which point? About which point? It is very, very important. About which point? Make a note here. I will dictate here. Always take moment about the point where two unknown forces are meeting. Two unknown forces are meeting. So that when you take moment about that point, moment of those two unknown forces will be 0. So among the 3, 2 will vanish. You get the other force. So when you take moment about the joint where two unknown forces are meeting. Remember that one. Okay, over. Now we will start systematically one by one. Time also counts. Therefore, I will write a neat sketch here and start one by one. Start now. Systematically solve. See, 3 questions are given. I noted down the member somewhere there. You cannot see it. First, you see the question there. First question. Calculation of axial forces in the members EF, BF, and FAB by method of section. Okay. Consider section you usually call XX. Since 3 questions are there, first question I will call X1, cutting above 3 members. Now, very important. If you want to really understand, you this sketch you write once again. Once again, write this sketch. How much time it will take? So that crystal clear. Now come here. See, That theta force are disturbing there. Okay, no problem. Okay, see, red color, anywhere cut. Okay. X1, X1, cut. This one, this one, this one. See, F, E, F. E, F or F, E both are same. Which one? In here, alphabetical order. E, F, E, F, B, F, and A, B. Now, class, consider equilibrium to any one side of the section. Come, you should write all these. Any one side of your choice, except for pin-jointed plane frames where two hinged support given. There, support reactions are not calculated. So, there you should not look support side. You should look other side. But here, we found support reaction. So, any side, see, anybody will tell looking left side is better. Therefore, okay, look left side. See here. Look left side. Or why look left side? See, leave it now. You consider the equilibrium to any side. So, consider equilibrium of pin jointed plane frame to left top x1, x1. Draw a neat sketch. See, you are considering equilibrium to left side. What you have to do is look this side. F and A are intact joints. F I wrote here, A I wrote here, VA upward, negative came, down 28.4, HA right side, negative came, left 36. This member is AF, we are not cutting it. Here, one member goes this way, one member goes this way, one member goes this way. Name the other side. See, these are the forces acting on left side from that side. Very important. That is, but towards the joint F. See, it is to the joint F. This also to the joint F, to the joint A. Forces acting to the joint F. See, F, F and A, this one. See, starting point. See, you can remember starting point. F, F, A. This is not internal, it is external. People who tell internal, they do not know the basic concept. Okay. Now see, by chance, if your question is to verify the result, then see here, F, E, F, E, this one, you take right side, see, this way, going away. F, B, you take coming towards the joint. A, B, see, A to B, A to B this side. This not that one, this one, 36. Don't see that one. It is actually this one, A to A, B. That is earlier classes when we are verifying the result. But now we are not supposed to look here. Why? Independent question. So, since it is independent question, confusion for more than 99% people, I told assume all of them going away, outwards. Assume all of them going away. Best option. Now, what to do is all over. This is inclined member. Okay, now, see, there is an inclined member here. Take pencil and mark here. Right component and down component. For resolution purpose later. Horizontal is cos, vertical is sine with respect to this angle. If this is not clear, you are not fit to study from me. Okay. Now, take moment about a point where two unknowns are meeting. Among the three unknowns, these two forces, Fe and Fb, are meeting at F. That's why take moment about F. F. See, why F? I told in the class. Clockwise positive. Start. If you take moment about F, see here, Pfe into 0, Pfb also into 0, 18 into 0, 40 into 0, even 28.4 also into 0, you get only these two. So minus PAB into 3 by anti-clockwise, then plus clockwise 36 into 3 equal to 0. Simplify. This you should do high school mathematics. PAB plus 36 kilonewton. Then sigma V0 take upward positive. Okay, now see, now you know the value of which one? PAB. Remember, unknown first. This will not come. Sigma V minus PFB sine 30.964 minus 18 minus 28.4 equal to 0. You get PFB minus 90.185. See, okay, no, not no. Sigma H equal to 0. Take right side positive. Now you know the value of PFB also. The only unknown is PFE plus PFE plus PFB cos 30.964 plus PAB plus 40 minus 36 equal to 0. By this time, you know the value of which one? You know the value of PAB. PAB is known and also PFB is known. Therefore, substitute PFB, whatever you got. Negative came, substitute negative, whatever you get, you substitute here. And substitute PAB plus 36. You get PFE. Simplify now. Now simplify this one. PFE plus 37.333 kilometer. Now, our final answer is C now. Just only for understanding. See correctly. These are the three members we want. See here. F2 from F, you took this way, FE. Answer came positive, so it is correct. See, opposite here. This answer is 37.333 kilonewton. I want, right? This force from the joint F, you took this way. See, this way. Negative came, so this is wrong. It is like this, opposite here. How much it is? 90.185. This force, joint A, you took this way. Positive came, correct. Same, 36 kilometers. Now see here, therefore, axial force in EF equal to, see, going away from the joint. 37.333 tensile. Next time I'll put only T, tensile. Axial force in BF is here. Any joint you see, coming to the joint. Coming to the joint is compressive. Compressive. Next time only C I will put. Here, acting away from the joint, tensile is the answer. Now, make a note. Actually, this is not required. Directly you can tell. See how you write here. We considered all the unknown forces to be going away from the joint. When you consider unknown force or going away from a joint, unknowingly for the member, it will become tensile. Remember. So, A became plus. So, correct. Tensile 36. No minus. Then FB came negative. FB. BF or FB. Therefore, compressive. And FE came plus. Means correct. Tensile. That also will do. Your choice. Next time, what I will tell you, we considered the unknown forces all going away from the joint. Going away from the joint means it is tensile in nature when you consider axial force. So, if you get positive, means your assumption is correct. It is tensile only. Suppose you get negative, assumption is wrong. It is not tensile. It is compressive, but no minus sign now. That is the best one to do. Or you prepare this sketch and tell the answer. Okay. Now, first question over. I'll go to two more questions now. Now, second part of the question, calculation of axial forces in members EF, BE and BC. See, EF, BE and BC. Those who are serious should write the sketch once again. See, remove that last one. I forgot last time. The last time, these three we got. Check the answer. Perfectly same. Okay, now consider section X2, X2, cutting these three members. This one, and this one. Okay, this way cut. Which side is better? I think still left side is better. Consider equilibrium of the pin-jointed plane frame to left of X2, X2. Then F, A and B are intact. F, A and B are intact. Then you are cutting here. So F force you should consider to the left, this left side to the joint F. Consider away from the joint. This is actually some recording problem. I am recording once again actually. Okay. See, going away, going away, going away. This force, and this force. It is actually from the inner joint. Okay. Now, everything is entered there. See where three unknowns are there. Take moment about the point where number two unknowns are meeting. Oh, it is B. So take moment about B. So take moment about B. See here. So that PBC into 0, PBE into 0, even this also into 0, even 36 also into 0. So what you get? Unknown is here. PFE into 3 clockwise. See here. Minus anti-clockwise 18 into 5. Then clockwise plus 40 into 3. Clockwise means plus there. Then anti-clockwise 28.4 into 5 equal to 0. You get the value of PFE. Plus will come. Now see, you got the value of PFE. Remember, sigma V0 take upward positive. Plus PBE, these are not there. Plus 77.4 minus 28.4 minus 18, 0, you get PBE. Sigma H0, take right side positive. See, now you know the value of PBE also. So unknown lastly, plus PBC plus PFE minus 36 plus 40 equal to 0. Substitute PFE, whatever you got there, you get PBC minus 41.333. Now, we considered all the unknown forces to be acting going away from the joint. See, respective joints away from the joint. When you assume a force acting away from the joint, you are actually imagining it will create what? Tensile force. But you got two negative. So PFE plus came. So tension 37.333. PBE and PBC, see, these two, we got negative sign, therefore compression. Check the answer. See, 37.333 tension here. 31 compression. 41.333 also compression. Perfectly tally. Sufficient. Now go to last part. Now, last part of our course, engineering mechanics, last part of part 5, last part of this question. We will be entering strength of materials next. Calculation of axial force in member, e.g. DE and CD. As I told you, later I will give strict warning for everybody. People who want to understand everything from me, what all I tell, they should follow. Lazy and not being serious, my class is of no use for you. I'm talking because I'm changing the colored pen. Okay. Therefore, I will tell you now once again. If you want really to understand, write this sketch once again. There, see, EG, DE, and this one. So, red color, X3, X. Consider equilibrium of the pin-jointed plane frame to, I think now better, to right side. So, right side. If you look right side, G and D are intact. See? G, oh, this is not E, this is G. Okay, okay. Print mistake. This is G. I don't know why it became, it is G. Okay, okay, print mistake. This is G. So this is PG, correct, I wrote correctly. G and D are intact. Then, see, this number also is there as it is. Here, for the joint G from this side outgoing away from the joint, P for GE. See, this one. And PDE, assumed left side. Not left side, away from the joint. I told all this one. And PDC, assumed like this. Okay. This is 2.5, this is 2.4. For this member, angle is 57 point theta 3, 57.381. Now, take moment about D. Or why D? See, among the three unknowns, two unknowns are meeting here. Take moment about D. Why D? I told in the class. See, in the class I am telling why it is D. See, I write here. Why D told in the class. Now, something else is there. See, when you take moment about D, PDC into 0, PDE into 0, 8 also into 0. These all will come. 16 into 2.5, no problem. 15 into 2.4, this is 16 into 2.5 clockwise, 15 into 2.4 anti-clockwise. I wrote there. That is no problem. But PGE is inclined force. So, when you take moment about D, what you require? From D, you have to drop a perpendicular to this line of action of the force. It is possible. You can drop a perpendicular. You know this dimension, this length you can calculate. You know the angle for that number. And using trigonometry, you can get it. I told it earlier. But complication. So, right here, class. Whenever you require perpendicular, simple means see, suppose by chance from A to here, if you want a perpendicular, see, H. Trigonometry, you get directly sin theta 1 equal to H divided by 5. You get very easily. But here, you have to extend the members, search distances all. You require this distance all. So, when complication comes, what to do is, right here, best option. Which member is causing trouble to you? PGE. See what all I tell. See, write what all I tell now. Which member you require moment of PGE, this force. So, you see, observe, decide one point which lies in its line of action. Known point. Yes. PGE, a known point is here. See, it is passing here. At that point, this force you resolve into component. Horizontally this way, vertically this way. See, this way. So this is cos, this is sine. With respect to this angle. Now very simple. See, take moment about D. See here. Minus PGE cos 57.381 into 2.5 minus PGE sine 57.381 into 2.4. Oh, in this one, I already explained, substituting, you get PGE. Sufficient. I told so many times earlier. Okay, now, sigma V0, I should do fast now. See, now you know the value of PGE is known. minus PDC minus PGE sine 57.381 minus 15 equal to 0. Substitute PGE, whatever you got, plus 1.187, we get PDC minus 16. Sigma H, now you know the value of which one? PDE also know. Okay. No, PDC also know. Okay. Now lastly, unknown is PDE. Sigma H0, take right side positive. Minus PDE minus PGE cos of this angle minus 8 plus 16 equal to 0. Substitute PGE, whatever you got there, you get PDE over. Now, I told last time, when you assume the unknown forces going away from the joint, we are actually, we are considering member is in tension. When a force is going away from the joint, it will result in tensile force. So, wherever you got plus, that means tension. Wherever you got minus, compression, no sign. So, final answer for EG, where is EG? EG is here. 1.187 tension, DE plus came. 7.36 tension, and CD or DC, where is it here? 16 compression. See the answer here? See? 1.188, 1.187, 7.36, 7.36, 16, 16. Yes. Therefore, over, remember, whenever we have alternate approach, different approaches from beginning of like centroid location, so many where equilibrium conditions, whenever you have multiple options, from beginning of the course, class number 1, up to today, class number, what? 383, I think. Everywhere, perfectly answer came. It also came in all the previous classes I uploaded before starting the course. More than around 1000 will be there, most probably. I don't know how many, not 1000. Yes, around 800, 900 is there. Also, it will come same way later when I continue the course. Especially when I go to structure analysis, consistent deformation method, strain energy method, moment distribution method, slope deflection method, Thani's method, column energy method, I may take matrix method or flexibility method, stiffness method, every method. If I tell this is the answer, it will be the answer. No chance of getting wrong answer. It will come. So that is the confidence I am having. Okay, now that I told. Okay, now over. I am going to conclude the class now. To all those who has gone through all the classes, thank you for at least using my effort. Such an effort you can make out. Now, those who are still listening, I am changing over to strength of materials. One information class I will upload where I will tell so many things. Then, if you want my course to be completed everywhere, so many things are there, entire structure engineering, you should see that my class reaches maximum people. But still, you are not doing it. You are using it and stopping it. And even nobody is liking also much. But like dislike ratio is very high. My channel ratio is 99.2. Means in 1000 people, 992 people liked it. Maybe 8 people are always there. There are people, okay, no problem. But still, you are not sharing, etc., not going to full class. That is your problem. I will do my duty. I have done my duty for engineering mechanics. I will continue it for strength of materials and other subjects. Hope at least now you will realize the importance of this course and you should know how much you stand to gain from my class. If I tell further, it will be boosting, so I will not tell. Okay, that's all. Thank you all.